All right, number 1, the square root of 36, that's just 6. Number 2, the square root of 81, that's just 9. Number 3, the square root of 24. Now that's not a perfect square, so we can break it down as 4 times 6. And when we take out the 4 by square rooting it, we get a 2. So we're left with 2 on the outside and then root 6 like that. Number 4, we have the square root of 98. Now again, 98 is not a perfect square, but 49 is a factor of 98, and that's a perfect square. So we'll write that like that. And we do that because we can take out 49 by square rooting it and get a 7, and this turns into 7 on the outside, root 2. Number 5 is the square root of 300. Well, 100 is a perfect square. So we can rewrite this as 100 times 3. Take out the 100 by square rooting it. Not sure where I got that line there. Okay, take out the 100 by square rooting it and get a 10. So this is going to be equal to 10 on the outside times the square root of 3. Number 6 is the square root of 1/4. So we take the 1 out by square rooting it and get 1. And we take the 4 out by square rooting it and get 2. So this is just 1/2. Number 7 is the square root of 5 over the square root of 3. Now, this is not a simplified fraction because you can't have a radical in the denominator. So we're going to multiply the bottom by root 3. So we'd have to do the same to the top. And that's going to become root 5 times 3 is 15. And root 3 squared is just 3. That's called rationalizing the denominator. You take an irrational number and you make it rational. Okay, number 8 is the square root of 80 over 25. Well, don't do anything to the bottom because we can take the bottom out just the way it is. That's going to become a 5. So this is going to be a 5 on the bottom. The top, 80 is not a perfect square, but 16 is. 16 times 5 is 80. And we can take out 16 by square rooting it and get a 4. So we're left with 4 on the outside, root 5, over 5. Now be careful, you cannot cancel these because one's in the radical, one's outside. You can only cancel outside the radical or both inside the radicals. All right, number 9 is 2 root 3 over root 12. There's lots of ways to do this, but what I would do first is cancel inside the radicals. So these cancel, that becomes a 1, this becomes a 4. So really what you have is 2 over the square root of 4. And the square root of 4 is 2. So this is just a 1. Okay, number 10 is the square root of 250 over 48. There's lots of ways to do this, but I'm going to start by canceling. Make this a 125 by dividing by 2 and make that a 24. So far I've got the square root of 125 over 24. And then I can even, let's see, actually I don't see how I can simplify anymore. So I'm going to make the bottom 4 times 6. And I'll take out the 4 by square rooting it, and I'll get 2 root 6. That's the bottom. On the top, I'm going to make this 25 times 5. And we'll take out the 25 by square rooting and get 5. So I'll have 5 root 5. And finally, I'm going to rationalize the bottom by multiplying top and bottom by root 6. So I'm going to get 5 root 30 in the numerator and 2 times 6. Root 6 and root 6 becomes just 6. That's in the denominator. So this is 5 root 30 over 12. Number 11 is the square root of 13 squared, which is simply just 13. Number 12 is the square root of 17 squared, which is just 17. Number 13 is 2 root 3 squared. Now when we square this and get 4, we square this and get 3. So this is 4 times 3, which is 12. Number 14 is 3 root 8 squared. Now when we square this and get 9, we square this and get 8. And that's going to give us 72. Number 15, we have 9 root 2 squared. And again, when we square this, we're going to square this and get 81, square this and get 2. So this is going to turn into 162. Number 16 is 5 root 18, and we need to simplify this. This is not simplified because we can simplify this further. So this is 5 times 18 is 9 times 2. And we can take out the 9 by square rooting and it becomes a 3. This 3 multiplies with that 5 and gives us a 15, and we're left with that root 2. Number 17 is 4 root 27. We're going to rewrite this as 4 times 27 can be written as 9 times 3. You take out the 9 by square rooting and it becomes a 3, and this 3 multiplies by that 4 that's already out there and gives us a 12, and we're left with that root 3. Number 18 is 6 root 24. Now we're going to rewrite this, the 24, as, let's see, 4 times 6. That's 24. We take out the 4 by square rooting and it becomes a 2. And this 2 multiplies with that 6 and gives us a 12. And we're left with root 6. Number 19 is 5 root 8. We'll rewrite the 8 as 4 times 2. And we'll square root the 4, it becomes a 2. This 2 multiplies with that 5 and gives us a 10. And we're left with that root 2 in the middle. Number 20 is 9 root 40. So we'll rewrite this as 9 times the square root. 40 can be written as 4 times 10. We'll take out the 4 by square rooting it and we'll get 2. This 2 is going to multiply with the 9 on the outside and give us 18. And we're left with the square root of 10 on the inside. Okay, page 534. Number 1 is negative 6 cubed. This is a negative in here, but this is odd, so it's going to remain negative because a negative times a negative times a negative is negative. So this will become negative. 6 times 6 is 36, times another 6 is 216. Number 3 is 3 to the negative 2. A negative in the exponent is just an inverse. So this is like the same thing as saying 1 over 3 to the positive 2, which is 1 over 9. Number 5 is negative 4 to the negative 3. Now, you can do this in any order, but if you want to do the negative first, you're going to invert this, and this is going to be 1 over negative 4 to the positive 3. And 4 times 4 times 4 is 64. And the negative is going to stay around because it's going to be multiplied out an odd number of times. So this is going to be a negative 1 over 64. Okay, number 7 is 5/3 to the negative 3. Well, I'm going to do the negative first, and that's going to invert this. So that's going to be 3 over 5 to the positive 3. And then we're going to cube the 3 and get 27. And we're going to cube the 5 and get 125. Number 9 is negative 1 to the 20th power. 1 to any power is going to remain 1. The only question is whether it's going to be a negative or a positive. Well, this negative is being multiplied out an even number of times, so it's going to become positive. So this is a positive 1. Notice if this was a 19th power, the answer would have been negative 1. Number 11 is 2 to the third times 2 to the second times 2 to the negative 4. Well, whenever your bases are the same, you simply add the exponents. That becomes 2 to the 1, which is just 2. Number 13 is r to the 5th times r to the 8th, which is the base is the same. Oops, let me do that in. And we get r to the 5 plus 3, which is 13. Number 15. You have r to the 9 over r to the 4. When you're dividing, you're subtracting the exponents. 9 minus 4 is 5, so this is r to the 5. Number 17 is a times a to the negative 1. There's lots of ways to think about this, but one way is this is an a times 1 over a. That to the negative 1 just inverts it, and then these cancel, and you're just left with 1. Number 19 is b to the 4th squared. Now, whenever you're raising an exponent to yet another exponent, you're multiplying, and you get b to the 8th. And you can think of it another way. Something squared means something times itself. So you can see now that this is b to the 4 plus 4, which is b to the 8th. But the shortcut rule is when you raise an exponent to another exponent, you just multiply. Number 21 is 3y squared times 2y to the 4th. Well, I'm going to multiply the 3 and the 2 and get 6. And then I'm going to multiply the y's, and the bases are the same, so it's 2 plus 4 is 6 power. All right, number 23, last one. We have 5a squared b cubed times a to the negative 2b. So when we multiply this, 5 times 1 is 5. And then we have a to the positive 2 and negative 2. That's a to the 0, which is 1. And we don't include a factor of 1. And then we have b to the 3 and b to the 1. It gives us b to the 4. And that's our final answer.